Hello and welcome to another episode of Building Microservices with Go, with me, Nick Jackson. In this episode we're going to look at bidirectional streaming and error handling. In the last episode we looked at how we can do error handling with Unary methods, but in this time we're going to specifically concentrate around the patterns for bidirectional streams. So let's dig in and start to take a look. So when we created in the last episode and we looked at the subscribe rates function, this is our bidirectional streaming method. Let's take a look at that proto, if I can find it. There we go, currency proto. So we have this method. It has a streaming request, rate request, and a streaming response of rate response. Now, in the instance that an error occurs in either the request from the client after processing or when you're sending the response, how do you handle the error messages? And the key thing is it's not that easy, because actually here you've got service.receive. Now you could kind of do some stuff. You want to do some processing, maybe save some things onto the database or something like that. There is no way of sending a direct message back to the caller that sent the message, again, which is actually just happening down here, where we're subscribing for updates in our products.go. But you can't send a response. If you return an error, what you're actually doing is you're terminating the connection. So you're stopping both the inbound and the outbound streaming connections when you return an error from this handler. That's why we block here. And I went into that in a little detail in the last two episodes. But we do need a way of sending a message back to the user. So how do we do it? So you think, well, it's a stream. Why can't I just send an error message back straight to the client? You've got to think about streams in gRPC as kind of like, think of it like a pipe. So it's a constant flow of water. It's one way only. So you've got a one-way stream for messages which are coming from the client, and you've got a one-way stream for messages which are going to the client. So there's no way to interrupt that stream. So when we want to send an error message, the only way we can do it is we've got to send it in the outbound stream. So let's say I'm processing some stuff in here. Let's have a look what we got. Well, we've got this subscribe. So what we're doing here is we're subscribing for currency rates. And we don't have any validation here. We're literally just popping these things straight onto a queue. But what if we want to do some validation? So what we're going to do is we're going to validate that the subscription doesn't already exist before we just add it on to the queue. So let's just run some code through there and see what that looks like. So we're just going to say check that subscription does not exist. So because our subscription is just a flat list, we can just loop over it. So we can just say for, do we want to get the key? Nah. Get the key, and let's just get the value, range, RRs, and then we can just do a test here. So we can say if v.base equals our subscription request, which is here, rr.base, and v.destination equals rr.destination, then the subscription exists. And we want to return an error message, just letting them know that that subscription already exists. Well, we've already said that we can't return an error from this function, because what that's going to do is that's going to break the connection. It's going to stop the client being able to send any more messages. And we don't want that. It's not a terminal error. It's more of a warning in a sense, I suppose, in this case. But what we can do is we can use the send channel, because this is a bidirectional streaming API, to send an error message back. But there's a small problem. And the small problem is that if you look at the type for the send back, it's just rate response. So it's just this message here. And actually, we want this message to be something a little bit smarter. We want it to potentially be a rate request. We want it to potentially be an error message. So how do we kind of deal with that? So what we can do is we can do something here, and we can say, right, let's define a new type. So we're not going to do rate response. We will call it streaming rate response. So let's put it down here, just beneath this one. And I'll show you a little trick. Streaming rate response. Okay. Now, what you can do in gRPC is you can have a message which contains messages. It's a kind of a hierarchical structure. And what we can also do is we can make a definition to say that a message can have one of a different number of different types. So we could say one of message. And I will dig into these in more depth in the next episode, but we can say that we're going to say one of, and we could have a rate response. I'm just going to call that rate response. Got to give it a position. Or what else could we have? Well, we could have an error. So we could actually have a gRPC status error as one of our types. And I can reuse this gRPC status like that. So I've now got streaming rate response, which is potentially could contain either a rate response or an error. Now, because we're using this one of, what's going to happen is that if I set rate response, if there's a value set for error, it'll get wiped out. And if there's a value for error, the same with rate response. So you can only have one of the others of the, yeah, I'm a little tongue-tied. You can only have one or the other set. There's one thing that we do need to do, and I'm going to show you that just now. So let's try and build our protos. So make protos error. So gRPC status is not defined. So I'm trying to use gRPC status here, and it doesn't exist. And that's because I haven't imported it. So if you think about the way that you import your Go packages with protos, you can actually import other packages as well. So I can import things like this status protocol from the Google RPC. And that's actually here. Protobuffer doesn't have a package manager like GoMod. So you've got to manually add these files into a location where they're expected. And you've also got to honor any of the imports, which this is bringing in. So that's pretty easy to do. If we go and look here, you see this is where we're defining our currency protos. So all we need to do in this folder here is add a folder, Google RPC, and then add a status.proto in there. And we can just copy that, or we can download it or clone it or set a Git submodule or anything you want. So I'm just going to add a new folder, Google, going to add a folder to that, RPC. And then in there, I can add a new file, which is going to be status.proto. And I can just copy that from this file here. Let me just paste that in there. There we go. So that's just in there. Now, it's still not going to compile because I'm waiting for this Google Protobuffer any as well. So it's in there, any not found. So we can do exactly the same thing, and I can just import any.proto from the repository at Google Gen Proto, Google RPC, blah blah blah. Again, I'm just going to follow that same convention. I'll put all of the links in the description for the video where you can get these files from, but they're also in the code repo. So do new folder, and we are doing any. So it is google.protobuffer, and we're just going to add any.proto, new file, any.proto. And I'm just going to paste in that any.proto file. I don't need to make any changes. I just need it in my repo. And of course, when I do my make protos now, you can see that that's passing because all of those dependencies exist. So we've now got our streaming rate response, which encapsulates one of two different message types. So let's update our subscribe rates function and just add streaming rate response. And again, I'm just going to have to build those protos. Right. So when we go over here, now wherever we're sending the send message, it's going to be broken. So we need to update that. But first things first, let's go through and look at how we can send that error message back. So what I want to be able to do is I want to construct an error message. So I want to construct an error message which says that the subscription already exists. So again, let's have a look. I can use our status convenience package, status dot, and let's do new F. I can choose my status code. So it's going to be codes dot, and already exists. Already exists means an attempt to create an entity failed because one already exists. Seems pretty sensible to me. So then I've got my error message, and I can say, I'm going to say unable to subscribe for currency as subscription already exists. And again, I can do some nice things. I can put some formatting on there if I want to. I can, all of those things. I can also add my metadata in the same way as I did that before. I'm just going to do s equals s dot with details. And then I can add my rate request just as metadata. So we can just say add the original request as metadata. And of course that with details that returns an error. We shouldn't get an error there, but we are going to defensively code that. We're just going to say if error is not nil, and we're just going to log the error message there. So we're just going to say c.log.error unable to add metadata to error. All right. And then we will just break out of that loop. So now we've created this error message, we've added the metadata to it, and we can send it back to the client using the send message. So the other end of that sort of stream. Send streaming rate response. Let's take a look at what a streaming rate response is. So it's protos streaming rate response, and we have message. So is streaming rate response message. So what this is actually doing is this is taking a message which is kind of implements this interface that it's suitable for this. It's a little bit sort of ugly, but it's not terrible when you consider it. It's kind of dealing with sort of pretty heavy reflection around there. So we can do our message, and the message that we're going to send back is this time a streaming rate response error. And a streaming rate response error is just that, that error type, which is just status.status. Let me just tidy this up a little bit so you can see what's going on. So doing that, streaming rate response. We're going to return our error. And our error is of type status.status. But not this status.status, because this is a different package. It's, we sort of dig into here. Let me just quickly show you this. The package here that we're dealing with is status, which is in the gRPC. It's gRPC status. The status that we're referring to there is this RPC status object. It doesn't matter. It's pretty straightforward. They do, we can convert this status into that the underlying raw proto status. Very easy. All we're going to do is doing s dot, and we can just do proto and get that raw type there. And whoa, and there we go. So we've satisfied that, and a big shout out to Mitchell Hashimoto, who helped me out with that, because I was a bit confused at how that was working this morning. But we can now send that error message back to the user, and we're just going to break out of that because we don't want to do this loop anymore, and we can just bounce out of there. So in the well, that's actually going to cause a problem, isn't it? So let's look at this just quickly before you catch my break on there. If you can spot the problem with this code. No? Well, what we're doing is I'm looping here, and I'm then going to loop through here. If I find something which matches, I'm breaking out of this for loop, but I'm still going to do the append there. So I just need to mark that error message. So let's just tidy this up here, and we're just going to say we'll call it var validation error status. And instead of doing s, we can do validation error. Let's just remove that. Whoops. Just tidy up here. We can say if validation error is not nil, send our error message. And if you scroll up, you see we're already in that loop there. So we can just continue. Otherwise, we're going to send if a validation error return error and exit continue. I'm just going to tidy up that code. Validation error. Okay. So again, we've got that error message there. We're appending. All okay. Just adding to the description and continuing. All right. Let me just tidy that. Okay. So now let's have a look at how we're going to handle this. And we're nearly done. We just want to take a look at how we're going to handle this error message inside of the client. So back over to the client code. So this is where we are the error is going to originate. So it originates because we're sending this rate request, which is a duplicate, a subscription, which is a duplicate. The error message isn't coming back here though. What's going to happen is we're going to get the error message back in our receive loop, which we're dealing with up here for handling the update. So this handle updates is monitoring for subscription updates from the currency server. So we're just getting those error messages, blah, and then we're doing this stuff there, right? But now the difference is that receive here is no longer a simple rate response, it's a streaming rate response, and a streaming rate response can be one of a number of different types. So what we can do is we can do a little check. So we can just say, well, we can say if RR dot, let's have a look. You see we got that message there. We've got error message. Okay. So what we're going to do is we're going to say if RR dot get error, if we've got an error back, we're going to do something. So we can check if this is not nil. Because we're using that one of, we can guarantee that either error or message will be populated in this proto. So if the rate error is not nil, then we want to handle an error message. So we're just going to do a log, and we could say here, we can say plog error. We're going to say error subscribing for rates. Well, we could say that and we're making some inference there, but remember that we can sort of, oops, sorry, let me just do it this way. gRPC error. We can then check, we can do things like checking the code. So the various different status codes, we can each handle those things differently because we've got that rich error message. We've also got all of the details and things like that. So you can kind of look at how that's implemented. I'm not going to implement that now. I will do in the example code so you can sort of pore over that, but it's literally the same as what we were looking at before. I just want to kind of show that here we've kind of got that error message. If we get that, then we just want to continue and start listening for the next message. The other state that we can have is that RR is going to be a message. So we can then say, well, if resp equals RR dot get rate response, and then we can say if resp is not equal to nil. Theoretically, we're guaranteed to hit this point because if get error is not populated, this one will be. That's because of that one of. We're just doing some defensive coding. It doesn't hurt. So we're doing get rate response, and we are going to say received rate from server, and then we can just do resp.get destination.string, and here. So I'm just updating this, but it's not wildly different from before. So this is now, you see how we can handle in our inbound stream, so our server to client stream, how we can handle messages which might be of a number of different types. It might be a rate response, a standard sort of application message, or it might be an error. This is the only way we can send errors when we're running a gRPC bidirectional stream. It's by sending it back down the client stream. There's just one quick thing I need to fix up in here because we do send those standard error messages here. So let's just change the format of this to a streaming rate response. And streaming rate response, if you remember, is going to have that message, which is going to be of a type. So we can say message, and the type is going to be one of. So it's going to be protos dot we're doing a rate response this time. We're just wrapping everything up in there. Protos dot rate response. I can just paste my original code back into there. So we're now going to send that error message back. We are using our new streaming rate response, which allows us to wrap and encapsulate a number of different error types, message types. So one error and one just our standard rate response in our client for our client stream, and we can send that back. Let's give this a run and see what's going on. Okay, so now we can get our product again. I'm going to get our product. Got our British pounds. That's all working great. We can see that we've made our subscription for our rate change for euros to British pounds. And you can see that we're getting that rate change back. But now let's try that with GBP again. So let's subscribe for the same rate twice. And we're going to be seeing in, there we go, in the product API, we can see that we've got this error subscribing for rates message back. And that was just that sort of quick message that we put in here. So, which I actually made a typo in. Let me just run that again so I can show you. Just quickly run that twice. There we go. So we can see we're getting that error message back. Error, unable to send updated rates, error, and then error subscribing for rates, code 6, we've got that rich message. And that is gRPC error messages. They're a little bit, I think they're very flexible. I like the fact that you can add the metadata. You've got the capability of putting the codes and things like that, and you can create really rich messages, which I actively advise you, and sort of, if you've got the time, please do it. It's a little bit awkward having to deal with sort of streaming protocols and handling messages on streams, but that unfortunately is just the nature of the implementation. It's fast, it's very, very efficient, but because of that, you've got to think of it like a fire hose. It's absolutely just one-way traffic. There's no opportunity to send a response direct to the request, and that happens for both the client and for the server. But we can get around it, and we can sort of implement things in this way. As always, I want to thank you so much for watching. I would love you to like and subscribe, and if you find this content useful, please let me know. If you don't, please let me know too, because it'll only help me make things better. Next time, we're going to be looking a little bit more in depth around protocol buffers and the different types of data that you can have and the different sort of ways that you can compose protobuf messages. And we'll kind of go through that, and we'll just dig into those things like any and arrays and some of the types that we've not covered so far. But until then, thank you so much again for watching.